Hello and welcome to Algebra 2 tutorial. In this video, we're going to take a look at the domain and range of root functions. We've been working with root functions for a while now. We've done their transformations, we've solved equations with them, and we're going to do one more characteristic with them. We want to be able to identify and describe the domain and range of these functions. And we're going to look at it a couple of different ways, but we'll be doing the same thing. So the three ways we're going to take a look at this are: if you're given a graph, can you identify the domain and range? If you're given an equation, or can you identify the domain and range after a transformation has taken place? So those are sort of the three sections of this domain and range category. So the easiest one is we're doing this from a graph. So we are going to start there. So the reason why this is the easiest is because you can see it. You have a visual. Now remember, domain is all the values of x that can go into the function, and the range is all the values of y that can come out of the function. So let's start with domain for this one. So that is the x values, where our function starts right here at 2, and then it goes on forever to the right, and so our domain are all of these numbers. So there's a couple different ways you can do that. In this case, I think the easiest is x is greater than or equal to 2. So that's all the values from the number 2 on we're allowed to plug into this equation, and those will work. If you wanted another way of doing it, you could say the interval from 2 all the way to infinity. That would also work. The x values go from 2 all the way to infinity, and so our range are the y values. Let's give this function a name. Let's call this function f of x. And so we would usually say f of x. Where can f of x be? Well, f of x starts right here, and then it does go up forever. It mostly goes sideways, but eventually it goes up and up as far as you want it to. Eventually it will hit 1 million, 2 million, 3 million. It gets up that high, and so it goes on forever, starting right there. So our function values are going to be greater than or equal to 4. If you want to do that in interval notation, you could. That would be from 4 to infinity. So there's our domain and range of that square root function. Over here we've got a cube root function. And so if we take a look at this, first the x values, we'll do our domain. So our x values, it looks like they go all the way that way. -8 has a value. It would go on forever that way. No holes in the middle, and it goes to the right forever as well. So our domain is all real numbers. None of them are left out. So now our range. So as the function comes down this way, it does go down and down and down forever. So we'll hit all the negatives. And as the function comes to the right, it's not going up very much, but it is going up. And it does go up forever. It does not flatten out. It does keep going up, and it'll eventually hit however high a value you want it to. It'll take a long time to get there, but it will get there. So our range is also all real numbers. Which is one reason why we're not going to talk about cubic functions very much. The domain and range is not very interesting. It goes down all the way, it goes up all the way, it goes to the left all the way, and it goes to the right all the way. So both answers are all real numbers. There's not much to do. We're mostly going to focus here on the square root functions because it's more interesting and there are more things happening. So that's how we get it from a graph. Now we're going to take a look at the domain and range from an equation. It's going to be very similar, We just have to take the equation and get a visual, and then we can identify the domain and range pretty easily. And so I picked a really complicated one here. And so I'm going to try to draw a graph of this, and then we can get the domain and range from that. So the first thing I see here is that we are being moved 1 to the left, and then 4 down. So -1, -4, and that is where our graph is starting. And then I see that we are being flipped over the y-axis, which means our graph is going to sort of be going this way. And we are also flipped over the x-axis, which means our graph is going to go this way, like that. So remember, our parent function is like this. When we're flipped over the x-axis, it's going to look like this. And then when we're flipped over the y-axis, it's going to look like this. So it did those two movements, so I know this is the shape I'm looking for. Alright, so I don't need to erase those. Now that we kind of know what our function looks like, we can identify the domain and the range. So our domain are the x values, and so it looks like our x values start right here at -1, and then they go to the left. So we're allowed to use all these x values over here, but nothing happens over here. There's no function, there's no graph over here. So we have to do all the numbers less than -1. So our x values are less than or equal to -1. Now let's do our range. So our range are the y values, and our y values start here at -4, and then they are going down. There's nothing above -4, everything is below -4. So y is less than or equal to -4. Now I use the y value there, that's perfectly fine. If you want to use f of x, you can also use f of x. They sort of are the same. F of x takes the place of y. Either one you want to do is fine. So if you have an equation, you have to somehow visualize it, and then you can get the domain and the range. You'll usually have something simpler than this. I tried to make something as hard as possible. Alright, last one. Finding the domain and range after a transformation. So we have this function f of x, it looks like, and we want to reflect it over the x-axis. And then we want to find the domain and the range. So let's do that here. So we're going to take f of x and do a transformation. So I'm going to call this new one, or it tells me what to call it, g of x is equal to f of x. And what are we doing to it? We are reflecting it over the x-axis. So remember, that puts a negative in front. So g of x is equal to negative, now I'm going to put in f of x, I'm going to put it in parentheses, square root of x plus 4 minus 2. And so g of x is equal to, now this is the tricky part, the negative does distribute. So negative square root of x plus 4. So a negative times the -2 becomes plus 2. And so now I want the domain and range of this. That's just like the previous one we did. We have to visualize that somehow. So we are flipped upside down. So here's my original parent function. And this one is going to be flipped upside down now. Kind of like that. Alright, but we are moving 4 to the left and 2 up. So I'm going to go 4 to the left. That'll put me at -4. And 2 up. So that will put me right here. And then I'm following this shape right there. So it's going to start there and come down. Okay. Try to ignore all my dashed lines. We are not doing domain and range of either of these. but that one there. So I think we are ready. Our domain are our x values. Well, the x's start here at -4, and it's everything to the right of -4 has a value. So x is greater than or equal to -4. And our range, let's see, we are starting here at +2, and it looks like the graph is going down. And so that is all the numbers that are less than or equal to 2. So if you have a transformation, do the algebraic steps. Once you get your final equation, you can then draw a quick sketch so you can visualize it, and then your domain and range is really easy. So there we had a good look at domain and range. You can find them from all of these 3 sources. A graph is the easiest, and if you're given something else, you probably want to visualize the graph somehow. So I would always recommend drawing that graph one way or another. So here are a few for you to try. Hopefully those make sense, and good luck.